All right, we're up to lesson 5 now. Lesson 5, we are going to talk about something called even functions and odd functions, and what makes a function even or odd. And also, is it possible for a function to be neither even nor odd? First things first. Let's look at the examples. Okay. And what we want to be able to do today is to either be able to determine even or oddness graphically, and we also want to be able to do it algebraically. If we look at the examples, you'll notice there's a mix of algebraic and graphical examples. So in fact, the directions say for number 1 and number 2, determine the answer algebraically, and for numbers 3 through 5, determine the answer graphically. So when we, for number 1, when we want to determine it algebraically, the first thing we're going to check is whether it's even or not. So we'll check whether it's even or not. If it is even, then we're done. If it's not even, then we'll check whether it's odd or not. Okay, so I put these functions over here so that I'll have a little more room. Let's go back to the lesson notes. So in order for a function to be even, this has to be true. F of x has to be equal to f of negative x. So f of negative x means replace x with negative x and simplify. If you get the same thing as the original function, the function is even. So f of negative x means replace x with negative x and simplify. So let's do that. So I'm going to take my function and so I'm going to take my original function, and wherever I see an x, I'm going to replace it with negative x. Okay, and then I'm going to simplify. And if I get the exact same thing as the original function, then that means the answer, that means the function is even. So let's check that. Let's first look at the first term, 3 times negative x to the power of 4. So what this really means is 3 times negative 1 x to the power of 4. This will be 3. And then the parentheses applies just to this part right here. So in other words, I'm going to raise negative 1 and x to the power of 4. So negative 1 to the power of 4 is positive 1. So this is going to be positive 1. And then x to the 4th is x to the 4th. So 3 times 1x to the 4th is going to be 3x to the 4th. Let's look at the second term. This will be negative 2 times negative 1x squared. So negative 1 squared is positive 1. And x squared is x squared. So negative 2 times 1x squared is negative 2x squared. And then don't forget to bring down the plus 1. Now, if I compare this to the original function, did I get exactly the same thing? 3x to the 4th, 3x to the 4th. Negative 2x squared, negative 2x squared. Plus 1, plus 1. So I got the same thing, which means the function is even. So we are going to say that this is an even function. Okay? If it's an even function, then I'm done. I don't have to check whether it's odd or not. I only check odd if I determine that it's not even. Okay, so let's take a look at number 2. And now we're going to do the same thing. So I'm first going to check whether it's even or not. So I'm going to take my function, x cubed minus x, and I'm going to replace x. I'm going to replace x with negative x. Okay. Remembering that negative x is really negative 1x. And if I simplify that, negative 1 cubed is going to be negative 1, and x cubed is x cubed. Okay. And then if we simplify this, remember there's really another imaginary 1 in front of the parentheses here. If I simplify that, this is negative 1 times negative x. Negative 1 times negative x is positive x. So this is really negative x cubed plus x. Do I get the same thing as up here? No, I don't. I have x cubed and negative x cubed. I have negative x and I have positive x. So this is not even. So because it's not even, I am now going to check whether it's odd or not. So let's go back to our lesson notes. Notice for odd functions, f of negative x equals negative f of x. F of negative x means replace x with negative x and simplify. We've already done that. Negative f of x means to change the sign of each term in the original function to its opposite, plus to minus and minus to plus. Okay, so if we go back to our function, this right here is f of negative x. We've already done that. Or in this case, g of negative x. Okay, so now I have to compare that to negative g of x. And again, what it says in the lesson notes, it means to change the sign of each term in the original function to its opposite. So I'm going to take the original function, and I'm going to take each of the signs of each of the terms and change it to its opposite. And I end up with negative x cubed plus x. If I compare that to this, are those the same thing? Negative x cubed plus x, negative x cubed plus x. Those are the same thing. So that means that this is an odd function. So this is an even function, and number 2 is an odd function. That's how we determine it graphically. So again, we first check whether it's even or not. We do f of negative x. Okay. By replacing x with negative x and then simplifying. If we get the same thing as the original function like we did in number 1, that means it's even. If we don't, that means it's not even. Okay? If we don't get the same thing, if we determine that it's not even, then we now have to check whether it's odd or not. In the case of number 2, we have to compare f of negative x, or in this case, g of negative x, to negative g of x. Okay? And when we compared those two things, we got the same thing. So we determined that it was odd. Okay, that's how we do it graphically, or that's how we do it algebraically. Now for the rest of the examples, For numbers 3 through 5, determine the answer graphically. Let's go back to our lesson notes. For even functions, notice it says the graph is symmetric about the y-axis. For odd functions, the graph has 180 degrees rotational symmetry about the origin. In other words, if the graph looks exactly the same when you turn it upside down, the function is, and this is actually a typo, that should say odd. Okay. So the function is even if it's symmetric about the y-axis. The function is odd if it has 180-degree rotational symmetry. In other words, the graph looks exactly the same when you turn it upside down. So let's look at number 3 here. So again, just like we did with algebraic, we're going to check whether it's even first. So the first question is, does this graph have symmetry about the y-axis? Okay, and I think it's pretty clear that it does. Okay, it looks exactly the same on the left side that it does on the right side of the y-axis. So this is an even function. And once we determine if it's even, we don't have to check odd.